Hello, everyone. Thank you for joining me for this new product webinar. First and foremost, I do hope that everyone is staying safe during these challenging times. My name is Richard Rodriguez. I joined Onset quite recently, actually this past October, to lead marketing activities for outdoor and agricultural products, along with my colleague in product management, Paul Gannett, which many of you may already have attended webinars with. My focus has been in developing our agricultural strategy and roadmap while helping improve our presence in the research and academics arena. Also, I'd like to note that, like many of you, I am working from home right now, along with my 2-year-old and 4-year-old girls, while my wife, being a nurse, cannot work from home and keep them quiet. So please excuse any little voices or possible shouting in the background. Don't be alarmed. It's just part of the times. Also, we do have Jessica from my marketing team in the background, helping to make sure that things run smoothly technically. So if you have any questions on audio, she'll be available to help you. This webinar is being recorded so that you or anyone can access it on our website after this webinar today. If you do have any questions, please type them in at any time into the questions dialog box at the bottom of your GoToWebinar control panel. I will do my best to get through some of them as I present, but I will be sure to get to as many of them as I can at the end. Also, thank you to anyone who did submit questions ahead of time. I did my best to incorporate those answers into the presentation itself. Also, after the webinar, I do ask that you take a couple of minutes to respond to the survey. It's a quick, just a few questions that will help us understand what we can do better moving forward with these webinars. Also, if you have any questions that I did not cover or you were able to ask in time, please just indicate that you would like for someone from Onset to reach out to you and we can provide you an answer after the webinar. So Onset, I assume many of you may be familiar with who we are, but Onset has been making data loggers known as the HOBO data loggers since 1981. Actually, since 1981, we have been assembling all of our products at our Bourne, Massachusetts headquarters. Quick agenda. This shouldn't take the full hour. Maybe we'll get to pretty close to the full hour with questions, but I'll do after a brief introduction. We'll take a look at Onset Soil Moisture Solutions, cover a few definitions that will help us understand the value of each of these new products, and we'll talk about the new products added to our line. Cover a couple of applications, installation, and then system components. But first, actually, I do have a quick poll. I'd like to understand how many of you are currently using data loggers. All right, just another few seconds. About a little over half of you have responded. All right, so it looks like 49% of you are using HOBOs, 27% are using other types of data loggers, and 23% of you are not using any data loggers. All right, so current problems. Many of the current soil moisture sensors out there are actually bare printed circuit boards with no actual protection from the soil, the elements that they encounter when deployed. So they can actually be damaged relatively easily during installation. Actually, installation is probably the point at which a lot of the issues occur. Movement above the deployed sensors and rough soils can also lead to premature failure, which can then lead to unreliable or just flat out bad results, which can affect your research or your decision making on a farm. Gypsum block type tension meters, tensiometers, also require a lot of prep work and maintenance, and in many cases are found to not last as long as they're needed to last. So they end up costing you a lot more in time to redeploy them. We also have customers in soil science and agriculture that require other types of measurements along with soil moisture, such as soil temperature and electrical conductivity. For agricultural applications specifically, many customers do prefer soil water potential type measurements, something like you would get in a tensiometer, which has really been a gap in our portfolio. And with that, I'd like to introduce the 3 new tools to the HOBOnet library or toolbox: the TEROS 11, HOBOnet TEROS 11, TEROS 12, and TEROS 21. We chose to, so TEROS 11, providing a volumetric water content or a percentage of moisture in soil and temperature. The TEROS 12 provides that volumetric water content, temperature, and electrical conductivity in one. And that TEROS 21 sensor provides soil water potential and temperature in a single device. We chose these to integrate these sensors from the meter group, so they are not our, full disclosure, they are not our sensors. We found them to be quite appealing to us, and given our relationship with meter group, we selected these given their high durability, high accuracy, and design features that ensure that the high accuracy that you may be looking for is maintained through installation while minimizing the impact of small variations in soil. So really all around great products. With that, our current soil moisture portfolio expands with the 3 options I just mentioned. So for HOBOnet, which I'll cover a little more in depth later on in the presentation, our wireless sensor network has the broadest offering with the EC5 and 10HS, which have been an integral part of our portfolio for years now. But now with the soil moisture temp and electrical conductivity and soil water potential sensors, and then for our smart sensor or a plug and play type sensor, still being limited to the 10HS and EC5. Now, I'd like to cover just a few definitions, just to help us as we move along for anyone that may be newer to soil moisture. First, volumetric water content. Basically, this is the ratio of water volume to soil volume. Typically, you can see it as meters cubed over meters cubed, or think of it as a percentage. These would be a majority of our soil moisture sensors from the 10HS to the TEROS 11 and 12. Soil water potential is the amount of energy required to move water in a medium to that of free water. This is always a negative number. You'll see this displayed as a negative number, and it is in either kilopascals or centibar typically. A lot of you may be familiar with probably one of the most common type of soil water potential sensors out there is the aerometer watermark, which you see at the right-hand side of your screen. And then finally, the tensiometer, which is an instrument designed to measure soil water potential, which typically these are used for spot checks. You can go around with these. These tubes would be filled with water, and you can penetrate the soil and get a reading for amount of water available to a plant. So if you look at the two, comparing soil water potential or volumetric water content, they do relate, but their relationship really depends on the type of soil that you're going into. The water potential measures the amount of stress required from a plant to absorb water that is in the soil. So depending on the amount of retention of water in the soil, you'll get a different, the same amount of water in the soil, depending on what type of soil will mean that different amounts of tension would be required from a crop to absorb that water. So if you look at sand, for example, with a dotted dashed black line, a small change in soil water content will create, which is on your x-axis, again, as a percentage, will lead to a large change in tension required for a plant to absorb that water. This is because the amount of air gaps or space between the grains of sand are large, and that allows water to move quite freely through the sand. So it's easy for your for a crop or a plant to absorb water from sand. When you compare that to something like clay, where the grains are much more tightly packed, you really have to increase the amount of water as a percentage by a larger amount in order to make it easier for your crops to absorb water. So again, depending on the different types of soil, as you can see here, your plants will need a different amount of water in order to be able to sustain a healthy level. Another way to look at it is over here on the right-hand side, where for crops, you really want to, in most cases, you want to be in this optimal range, which is from negative 50 kilopascals to negative 20 kilopascals. And as you can see, in what that corresponds to in volumetric water content for sand and clay, those are two very different values. So this is one reason why for farming, the soil water potential devices are preferred, because there is one value that can be used as a rule of thumb for regardless of the type of soil that you're deploying these in. You don't need to really worry about any variations in that soil type. And finally, electrical conductivity. Electrical conductivity measures the amount of salts in soil. It is an important indicator of soil health, and that has large implications to crop yields and the health of a plant. Electrical conductivity is correlated to the concentrations of nitrites, potassium, sodium, chloride, sulfates, and ammonia. So for anyone looking to understand how the concentrations of these different items may change as you apply fertilizers and apply irrigation, electrical conductivity sensors may provide you a good way to do that. So now to get into a little more detail on the devices themselves, the HOBOnet TEROS 11, again, it measures soil moisture as a percentage of soil, as a percentage of volume, and temperature in one. These are known for a long lifetime, very high durability with up to 10-year usable life in the field. So again, their near bulletproof form factor means that you can deploy them and leave them deployed year after year without having to worry about having to pull them out for for the winter, for example. One great thing that we really like about these is that they are small, but create a large volume of influence. So they actually have the largest volume of influence to their size. So they measure about 1 liter of volume, or a little over 1 liter of volume of soil. And what this means is that it actually compensates, these devices compensate a little bit more for any small variations in soil. So if there's any variations because of the larger volume that it's reading, like having a rock or a large body there, a small air gap, the measurement will be less affected by that. The sharpened stainless steel needles make installation easy. So it's a lot easier to push those into the soil with less worry of damage or deterioration. So a big concern with like the printed circuit board type devices is that when you push them into soil, that they get scratched, damaged, and that your results will not be any good after collecting the data. And they're also known for less sensor to sensor variability. So you can deploy these in a large field and compare point to point with a high degree of accuracy from point to point, knowing that those readings will be repeatable. The HOBOnet TEROS 12 pretty much has the same features as a TEROS 11, but with the added ability to measure electrical conductivity. And one other difference is the location of the thermistor, so where it takes the temperature measurement for the TEROS 12. The center needle is where the temperature is measured, which makes this actually it allows this device to sense changes in temperature more quickly because of that location. And also this would be the preferred device for anyone measuring moisture or electrical conductivity in non-soil type media. So if you're doing indoor growing, this would be a device for you to consider. The HOBOnet TEROS 21. Again, measure soil water potential and temperature in one. For a lot of people, it will provide a more accurate picture of water available to plants. Again, it's providing a direct measurement of stress on a plant, how stressed a plant would be to pull water from the soil. Results for this device are not dependent on soil type or salinity. So as you increase the salinity of soil by applying fertilizer, it's going to show you that the amount of water available to your crops may decrease because of that increase in salinity. So it may actually be more usable to you. This is long lasting and maintenance free compared to a lot of other soil water potential devices out there. This product is made to last. It uses a durable epoxy that allows it to last in the ground. Doesn't require any type of refilling, or you don't have to worry about freezing conditions. And then it does provide a wide measurement range, so from -2,000 kilopascals to -9 kilopascals. So well beyond both borders of where you would want to be in terms of how dry your soil should get or how wet your soil should get for your crops. In terms of calibration, for higher accuracy, so the TEROS 11 and 12 are factory calibrated for mineral soils. For potting soils and soilless media such as perlite and peat, you would have to use a generic type of calibration, which would get you accuracy to better than 0.05 meters cubed per meters cubed. If you're looking for to improve accuracy beyond this, then you would have to perform media specific type calibration. We can help with this. The TEROS 21 does not require calibration. Again, you can deploy it in different types of soil. It doesn't care what type of soil it's in. or the salinity level of soil. I did receive questions prior to the webinar on regarding the application of these devices in soilless applications. So yes, the TEROS 11 and 12 are great for this type of application or applications in media other than mineral soils. Again, we do recommend the TEROS 12 if you're looking for temperature measurement that is more sensitive. So for applications in agriculture, of course, irrigation. Irrigation is probably one of the larger reasons or sources of sales for these devices. Soil moisture sensors can help you determine when to water crops based on plant demand, as opposed to your typical scheduling. We have several customers that actually really like to use these devices planning ahead. So say you have to apply some type of pesticide and you just want to make sure that you can hold off on irrigation for long enough for those pesticides to take effect. You can look at a chart like what you see on your screen right there and look at and consider the rate of decline of soil moisture and make a decision based off on that. One factor to consider if you're deploying these on uneven terrain, you will want to understand that account for different levels of that terrain. So understand that water flows downhill. So this will lead to different areas getting more water than others. Different directions of sloping sides of a hill will also mean different levels of sun exposure and wind, which means that you'll have different rates of evaporation or evapotranspiration. So you'll also want to account for this when determining how many soil moisture sensors you would need. The number of soil types present in the because again, the type of soil will change how much water is available to your crops. You would want to add a soil moisture sensor for different to each site or a microclimate where you would with different types of soil. Type of irrigation will impact how many you need. Some sources say that for furrow type irrigation, you would want to have 2 sensors, one third of the way down a furrow, the second 2/3 of the way down. For pivot irrigation, because of the amount of time it takes a pivot to complete a churn, you would want to use a minimum of 2 soil moisture sensors, one immediately after the starting point of the pivot and one just before the end of that pivot. And this is because, again, if it takes you 30-something hours for that pivot to complete a churn, when you may not want to wait for that first point to get dry to start irrigation, because by the time it completes a churn, the crops on the back end of that churn may be below that optimal range. For drip type irrigation, the recommendation is about 1 soil moisture sensor for every 12 inches of root depth. For research, I did get a few questions regarding research type applications. We've worked with clients recently looking at the effects of decreasing irrigation on soil and crops. So in different areas, there are a lot of activities going on or thoughts on decreasing the amount of water usage, especially in arid climates, and the studies are in place to understand what that means for soil health and of course crop yields. Assessing salt marsh responses to sea level rise, the sea level rise being a big topic of concern right now, and then effects of human activities in wetlands. So whether it be urbanization or agriculture, different activities, different changes in the environment around wetlands, of course, has affects wetlands. So understanding how changes in water level, soil moisture, and salinity, and then what those effects are on the flora and fauna in those wetlands can be. So which one to choose? Which device would be best for you? Well, it really depends on the application. Of course, volumetric water content really do provide a good basis for decision making in agriculture, and then in research, of course, in many cases these do provide the results that one would be looking for. But if you're in a research type application and you don't have irrigation, and you know that the soils, the shrink ratio, the shrink swell ratio potential of the soil is high, meaning that as the soil dries out, it's really going to shrink and crack. This will create air pockets, maybe some gaps between the soil and the sensor. In this case, you would actually want to go with a volumetric water content sensor rather than a soil water potential sensor, because the soil water potential sensor really does count on a tight pack of soil around the sensor. However, for volumetric water content, the results will vary with soil type, or you would have to understand how what the effects of different soil types would be, and the salinity level would be on your readings. So if you're looking for an easy point-to-point comparison, the soil water potential may be the best solution for you. Now, looking at system components, these three sensors are part of the HOBOnet system. And so these sensors would need to be set up with either the RX2100 or RX3000 series logging stations. You would have options for cellular, Wi-Fi, and Ethernet connectivity. These stations can connect up to 10 wired sensors and 50 wireless sensors per station and data plan, which make the HOBOnet solution pretty much the most cost-effective method to monitor a field with a sensor network. So if you're not looking at just a single point of measurement and you want to understand how things change over several points in a field, HOBOnet really does provide a very cost-effective solution to do that. And then to view your data, you would use our cloud-based platform, HOBOlink, where you can do some analysis, or you can export all your data into a CSV or an Excel file, so that you can analyze it on your own software or just view it in an Excel file. Now, in terms of installation, for the HOBOnet TEROS 11 and 12, this is quite simple. You would dig a hole just below the desired measurement depth. You would want to insert the device as you see it there, with a body vertical and needles horizontal. You would want to push those needles into virgin soil, so untouched soil, and then you want to backfill the removed soil and pack it to match the density of that undisturbed soil. If the sensor needles become contaminated with oils because you touch them with your bare hands, so skin oil or oil from another source, the needles should be cleaned off to ensure proper accuracy of the electrical conductivity measurement. And this can be done by just using simple mild detergent such as dish soap. For the HOBOnet TEROS 21, you would want to cut or auger a hole again to the desired depth. You'd want to moisten some native soil with water, and then pack that soil around the sensor, ensuring that there's a tight contact with all the surfaces. If you have sandy soil where this is not possible, where the soil wouldn't adhere to the sensor, you just place the sensor at the bottom of the hole, moisten the sand, and then pack the sand over the sensor disc. For shallow installations, you can use a small knife to remove a small sliver of soil and then push the packed sensor into that small hole. For deeper installations, you'd want to create a slurry of native soil and water and then place the packed sensor at the bottom of the hole, much like I explained with the sandy conditions. And then for all cases, HOBOnet 11, 12, and 21, you'd want to protect the cable with conduit or plastic cladding of some type, just to protect the cable from any rodents, any wildlife burrowing through there. Now, looking at the two stations that you would want to get for two HOBOnet stations, you really have two options. You are the 2100 and the 3000. The 2100 has an indoor and outdoor option. They really provide similar type of capabilities, with the 2100 being the lower cost option, which would suffice for a majority of applications. You would, however, have to go with the RX 3000 option if you want either Ethernet or Wi-Fi connectivity. If you're looking to pair up these soil moisture sensor devices with a water level measurement, if you need more than 5 wired sensors, and then if you're looking to just add any other modules such as a 4-channel analog input or a relay, basically an output that would allow you to initiate an activity after a preset threshold of any of the sensors you have hooked up here. Say, soil moisture drops below a certain point, you can initiate a pump. Then the RX 3000 would be the solution needed. In terms of pricing for these devices, again, I do list more than 3 devices here, just because the numbers after the dash, so the last 3 digits refer to the radio frequency of the communication. So you would need to specify that for each region of the globe you're in. So for the TEROS 11, soil moisture and temperature, you're looking at $395. For the soil moisture, temperature, and electrical conductivity, that is $450. And this is for the sensor and data logger radio combination. And the TEROS 21 is $495 again for the sensor itself, the radio, the radio and data logger in one. As you can see here, it's basically a 2-in-1 unit. Now, I did get a lot of questions ahead of this regarding the cost of these, and to give you an idea of how much it would take to get started on this. And this actually helps me to kind of give you a picture of how to compare different systems, such as a HOBOnet system, to someone else. So HOBOnet is meant to be very cost-effective in creating a sensor network. So if you're just looking at purchasing a single sensor and taking measurements at a single location, this is going to be quite expensive. So our solution for the RX 2100 with HOBOnet capability, you're looking at $770 for an outdoor application. The sensor is $450, so you're looking at a little over $1,200. You can actually get that from another manufacturer for $875. Now, this does exclude the data plans, and in terms of data, we tend to be on the lower end. We do provide very low-cost options, but just from a hardware point of view, this probably isn't the best solution. We do have other lower cost solutions. However, if you're looking at measuring soil moisture at 3 different locations, single depth, but you have perhaps it's an orchard or a research site where you need three different locations. Now you start to see that our cost becomes the lowest available. So again, you would still only need a single station, which it provides your data logging and communications capability, and then with 3 sensors, that would be over $1,300 for those 3 sensors, so a total of $2,120. if you're looking for a lower cost solution for soil moisture, we do have the EC5 and EC10, which run about $249 each, which is about a $200 discount compared to the TEROS 12. The TEROS 11 again is at $395, so that would save you $50 as well. In terms of accessories, we do offer the TEROS verification clip, which provides an easy method to verify the operation of both the TEROS 11 and 12 devices. This makes it easier to verify that one, the device is operating correctly, and two, that the accuracy is what you expect it to be, because this is compared to doing this verification in either open air or water, because it really focuses on the range of peak frequency, peak accuracy for these devices, and it does ensure the highest sensor-to-sensor repeatability. So if you're doing a research work and you want to again compare several points using this clip, which costs about $35. Yeah, I think the price is $35. Pretty much a no-brainer to ensure you're getting that sensor-to-sensor repeatability. If you choose not to go with that, and you're just doing the verification in either open air or water, then the device will give you a reading of about 0.7 meters cubed in water and a slightly negative value in air. And with that, I've reached the end of the presentation, and I'll open this up to questions. So if we have to maintain a soil water holding capacity of no less than 60%, how do we interpret this on a volumetric data logger? Not completely sure I understand the point of that question, but you're looking to relate the full what percentage of your holding capacity to a measurement on a data logger. I want to say that you would multiply that 60% by whatever the max capacity for that soil is. So say it's a 0.4 meters cubed per meters cubed. Then you would multiply 0.6 by 0.4, which gives you 24%. But I may want to reach out to you just to make sure that I understand that correctly. Can I use these sensors with Orange Pi, Raspberry Pi? You can, I believe you can. However, in that case, you probably don't want to buy them from us because we attach them to the HOBOnet data logger and radio, which means you have to pay for that. You may want to just go reach out to Meter and purchase them directly from just the sensor itself, unless you do want the data logging portion of it. But I'd have to understand what that need is. Will these work reliably in sand? Yes, actually, one of the advantages of these devices is that they're high durability. That those stainless steel tips make it so that you can, with peace of mind, bury them in sand and leave them deployed there. I was actually one of the big challenges with a printed circuit board type sensor is that sand, those large grains, can really cause damage to the sensor during installation, or just with a lot of movement in the sand above the sensor. That will not be the case here. So yes, perfect devices for sand. Can the data be obtained directly, or does one need a HOBOnet network account? You would need HOBOnet. However, depending on your amount of usage, how many sensors, and available local network, you can that can cost you nothing. If you do need a cellular plan, then those start at $150 per year. Do I leave a data logger out there and plant over, or how do I leave a data logger out there and plant over top of it? So yes, we do have a lot of users that leave these deployed. Now, really, the challenges there depend on the type of crop, whether it's a permanent crop or yeah, you're going to be planting over it. Of course, you'll leave the sensor buried to whatever root depth you want to measure, and then the radio itself will you'll want to put that up high. If you can do so, we recommend placing it above the canopy and the crop canopy. And if possible, well, and we highly recommend marking that location with a flag, a bright color, so that you see that when you're during planting or different activities on the farm, so that you don't accidentally strike the post you have these mounted to. And this is if you want to leave it deployed. In some cases, depending on the type of activity, type of soil, maybe easy, and depth of installation, it may be easy enough for you to pull them in and deploy them after planting. What is the typical expected battery life of a TEROS 1121 sensor reading one time per day? So regardless of the reading one time per day, you can even read more often than that. With our nickel, the nickel batteries that ship there, these do have a solar power. They are solar powered, so the batteries are recharged. So if you can actually have them deployed in the sun, these batteries will last you 3 to 5 years when operating at a temperature range of negative 20 degrees to 40 degrees Celsius, or negative 4 degrees Fahrenheit to 104 degrees Fahrenheit, and positioned towards the sun. If they operate outside of this range, then the battery life will be reduced, but you'll be able to deploy them again for, in most cases, for over a year. If you're doing deployment indoors, where you're not solar power is not feasible, you would replace the batteries with lithium batteries, which we do provide, or you can just order them from a third party. They are 2 AA batteries. Then you get 1 year typical use. But we do provide more details on this in our manual. Can you also mention new soil moisture sensors and loggers for where there is no data, Wi-Fi coverage, and satellite is too costly? Yes, our 10HS and EC5 smart sensors, so the plug-and-play sensors, can be deployed with either our U30 or H21 data loggers, which can log data for years, and then be offloaded via USB. So you would have to walk out to these devices and do the local offload. Any sensors for recording soil nutrients? Not directly, not specific nutrients. So we covered the electrical conductivity option with the TEROS 12, which is correlated to the concentrations of nitrites, potassium, sodium chloride, and sulfates, and ammonia. So you can correlate it, but not to any specific one. Can sensors be left in the ground during winter freezing conditions? Yes, they can. However, for frozen soil conditions, frozen soil conditions will impact the measurement. So there are actually certain adjustments that need to be made if you actually want to use this data during the freezing conditions. Does one module drive 2 soil moisture sensors? No, each data logger radio has a single sensor attached to it. Let me do a time check. We still have a few minutes, so I will. What if I need to measure deep into the soil, example 2 meters deep? How deep can I deploy the TEROS 12? Can the sensor work down 4 meters below ground surface? Yes, for the cable length will work. Installation will be more challenging. For 2 meters deep, that your biggest challenge will be actually digging the hole and burying the and getting the device to that depth. How deep does a TEROS 21 need to be buried? So that you would want to measure at the root depth. So you would want to, that really depends on what you're trying to achieve. If you have a specific crop, you can reach out, or we can reach out to you to make a recommendation. Is the probe to the TEROS 21 designed to be buried at a set depth in soil? Yes, so these all these devices, they're not meant for like a spot check where you walk around and bury them a few inches and take a reading. They are meant to be deployed over time and collect data over time. So they're not so sensitive where you walk up, bury them for a couple seconds and take a reading. So you want to understand based off of what you're trying to achieve, determine what the required depth is, and again, we can provide recommendations there. Could these sensors measure the presence of metals in soil? So yes, that's actually part of the presence of metals will impact either the electrical conductivity reading or the amount of water available to crops. Typically in agriculture specifically, you're worried about increasing, say, iron content in soil and how that impacts your need to water. So in that case, if that's what you're trying to achieve, then like the TEROS 21 can help you there. If you're looking to identify a specific item, then no. How can you determine the permanent wilting point of the plant you are measuring specific to your soil? So you will know the baseline level and avoid lack of water damage from plants. So to the permanent wilting point, if you're not quite sure what your soil type is or independent of soil type, then again, the TEROS 21 would be the tool for you. And then I want to say that you're, depending on the crop, you can find different information for specific crops on what that permanent wilting point would be. There seems to be, I'll leave it at that. Are there options for connecting these sensors to BMS? Can we integrate the controllers directly to our BMS? We don't have that. Our RX stations don't currently have that capability. We do offer we do have an API that would allow you to automatically pull the data from HOBOlink and dump it into an FTP site, for example. I need to use it for architectural purpose to measure the energy escaping from the building. So I need to measure the temperature in soil moisture content only. Deep into the soil, which of your products do you recommend? For temperature and moisture content only in a single device, the HOBOnet TEROS 11 would do the trick. If you don't need that remote monitoring capability, you can come to a combination of say an H21 with an EC5 and a separate temperature probe. But again, I'd like to understand, get a little more detail on what that application requires and entails, and we can make a better recommendation based on that. And finally, if the soil moisture sensor is paired with an RX3000 with a relay output card program to trigger on a specific level, what is the delay between the sense trigger point and the activation of the relay? I would need to, I'll need to get back to you on that. On the alert is initiated at the sensor level, so not online, not in the cloud. So it is rather quick, but I'd need to check with my engineers on how many minutes that communication takes. How do I best calibrate for high organic soils, marsh, and detritus soil? We have regarding better calibrating, we can help with those calibrations. So we do have generic equations for this, but I would need to work through that specific for higher accuracy specific calibration. Does a HOBO station link with the correct sensor have? So I don't believe I understand this. This final question: does this HOBO station link with the correct sensor have the ability to generate soil moisture release curve? I will have to get back. I have to apologize. I don't have that answer. And it looks like this is it. Thank you everyone for your time. Again, I ask again that you please take a couple of minutes to answer the quick poll at the end of this, and if you would like for us to reach out with a couple of with any specific answers or recommendations on applications, please indicate that you would like someone from Onset to reach out to you, and we will be sure to do so. Thank you again.